How transaction fees work on exchanges and wallets. Explain to me what cryptocurrency gas fees cost in a transfer. Cryptocurrency gas fees refer to the cost associated with performing transactions or executing operations on a blockchain network. Gas fees are typically associated with blockchain platforms that utilize smart contracts, such as Ethereum. In the context of Ethereum, gas fees are paid in Ether, ETH, and are used to incentivize miners or validators to include and process transactions in the blockchain. These fees help maintain the security and operation of the network. The cost of gas fees for a transaction can vary based on several factors. Network congestion. During periods of high demand, when many transactions are being processed on the network, gas fees tend to increase. This is because users are competing to have their transactions included in the limited block space available. Gas price. Gas price is the amount of Ether you are willing to pay per unit of gas. It determines the priority of your transaction within the network. If you set a higher gas price, miners are more likely to include your transaction in the next block, but it will also increase the cost. Transaction complexity. The complexity of the smart contract or operation being executed affects the gas fees. More complex operations require more computational resources and, therefore, cost more in gas fees. To estimate the gas fees for a transaction, you can use blockchain explorers or wallet interfaces that provide information on current gas prices and estimate the total cost based on the complexity of your transaction. It's important to note that gas fees are subject to change and can be volatile. Different blockchain networks may have different fee structures, so it's essential to check the specifics of the network you are using to get accurate information about gas fees. Explain transaction complexity more detail. Transaction complexity refers to the level of computational resources required to execute a transaction or smart contract operation on a blockchain network. It determines the amount of work that needs to be done by the network's nodes or validators to process and validate the transaction. In the context of Ethereum, transaction complexity is primarily influenced by the following factors. Smart contract operations. If you are interacting with a smart contract, the complexity of the contract's logic and the number of operations involved can impact the gas fees. For example, executing a simple transfer of tokens may require fewer computational resources compared to a more complex operation like deploying a new smart contract or executing a series of conditional statements within a contract. Data storage and manipulation. Transactions that involve storing or modifying data on the blockchain can have varying levels of complexity. Writing or updating large amounts of data can require more gas fees as it involves more computational work. External calls and interactions. Interacting with other smart contracts or making external calls to off-chain systems can add complexity to a transaction. Each interaction with external contracts or systems requires additional computational resources and, therefore, increases gas fees. Loops and iterations. Transactions that involve loops or iterations, where a particular operation is repeated multiple times, can be more complex and resource-intensive. Each iteration requires additional computational resources, leading to higher gas fees. Storage and memory usage. Storing data or variables within a smart contract storage or memory consumes gas. The amount of gas consumed increases with the size of the stored data. It's important to consider transaction complexity when estimating gas fees, as more complex transactions will generally require higher fees to compensate for the additional computational resources and time required to process them. When developing or interacting with smart contracts, optimizing transaction complexity can help reduce gas fees. Developers can employ techniques like code optimization, minimizing storage usage, and avoiding unnecessary iterations to make transactions more efficient and cost-effective. External calls and interactions is when you take it off exchange or out of wallet to your bank. or wallet to PayPal then to your bank cost more fees. Correct? External calls and interactions, in the context of blockchain transactions, refer to interactions with other smart contracts or external systems. It does not specifically pertain to transferring funds from a cryptocurrency exchange to a bank or using services like PayPal. When we talk about external calls and interactions, it primarily involves invoking functions or accessing data from other smart contracts or interacting with off-chain systems through oracles. In the case of transferring funds from a cryptocurrency exchange to a bank account, it typically involves a withdrawal or a sell order on the exchange platform. The fees associated with this process are specific to the exchange and may include withdrawal fees or trading fees. These fees are not directly related to external calls and interactions on the blockchain network. Similarly, when using services like PayPal to transfer funds from a wallet to a bank account, the fees involved are determined by PayPal's fee structure, which may include transaction fees or currency conversion fees. These fees are not directly related to blockchain gas fees or external calls and interactions. It's important to note that each platform or service has its own fee structure, and the fees associated with transferring funds between different systems can vary. It's advisable to check the specific fee schedules and terms of the platforms or services you are using to understand the costs involved in these transactions. Thanks for watching.